Assalamualaikum warahmatullahi wabarakatuh. Hello guys, introduce myself. My name is Valda Nafila with name 4101422060. In this video, I will discuss a little about proof injective, surjective, and bijective function with Geogebra and Algebra. Okay, before that, I will explain you about meaning of injective, surjective, and bijective function. Okay, next. Okay, function. Let f a to b is function from a to b. Okay. Function f is said to be injective if for any f x1 not equal x2, then fx1 not equal fx2. B. The function f is said to be surjective if fa equal b, which means that the range of f is b. And C. If f is injective and surjective, then f is bijective. Okay, next. Okay, injective function proof. To prove a function f is an injective function, then we have to show that if and only if every x1, x2 element A and x1 not equal x2, then fx1 not equal fx2. We can also use contradiction. Every x1, x2 element A and x1 equal x2, then fx1 equal fx2. That is, by assuming that fx1 equal fx2, then it will be proved that x1 equal x2. If we use Geogebra, we can also do the proof with the horizontal line test. Every horizontal line y equal b, b element uppercase b, then the line will intersect with graph f only at one point. Okay. The next surjective function proof. To prove that a function f is surjective, we must show that for any y element b, then there is at least one x element a, so fx equal y. If we use Geogebra, we can also do a horizontal line test. Every horizontal line y equal b, b element uppercase b, then the line intersects with the graph f at least at one point. In other words, minimum at one point. Okay, let's go to Geogebra. Okay, I have a function. Gx plus 5. Okay. Okay, this is the function I met and this is the graph. Now we will identify whether this includes an injective function or not. Okay, therefore we need a horizontal line. Before that, let's write, for example, y equal 10. Okay, this is an injective function because only intersects in at one point. Okay. If there is horizontal line that intersect at only one point, then this is an injective function. Okay, injective function. We replace, for example, 2. Okay, this is injective function 2 because only intersect at one point. Okay, now we will identify whether this includes an surjective function or not. Okay, for example, 20. Okay. If there is one horizontal line that intersects a least at one point in the function I created earlier, then it is a surjective function. Okay. Okay, minimum. Okay, minimum at one point. So this is a surjective function. For example, we replace it with minus. Okay, sample minus 9. Okay, okay. This is also the same, right? Only, I'm sorry. Intersect at minimum 1 point. Okay, so this is surjective function. Okay, now let me try to prove with algebra. Okay, injective function proof. Check if f real to real with fx equal 3x plus 5 is injective. For every x1, x2 in the domain f, x1 not equal x2, then fx1 not equal fx2. Take any x1, x2 element real with x1 equal not equal x2, it will be proved that fx1 not equal fx2. Clearly, 3x plus 5 not equal 3x plus 5. 3x1 plus 5 not equal 3x2 plus 5. Okay, we remove 5, so only x. Therefore, we subtract by minus 5. So, 3x1 not equal 3x2, x1 not equal x2. So, this proves that fx equal 3x plus 5 is injective function. Next. Surjective function proof. Check if f real to real with fx equal 3x is surjective. For every y element real, that is x element domain f, such that a y equal fx. Check any y element real, choose x element real. Okay, fx equal 3x plus 5. Okay, fx equal y. So y equal 3x plus 5. We move 5 to left side. So y minus 5 equal 3x. Y minus 5 over 3 equal x. We substitute uh, y minus 5 over 3 equal x to function. So clearly fx equal 3 times y minus 5 over 3 plus 5. Okay, y minus 5 plus 5, fx equal y. So this proves that fx equal 3x plus 5 is a surjective function because a bijective function is a function which is an injective function and a surjective function. So the function fx equal 3x plus 5 is a bijective function. Okay. To GeoGebra. I have another function. Okay. Okay, this is a graph of function x squared plus 10. Here I have written the test point. For example, y equal 5. Okay. And this has been proven that the horizontal line not injective function because intersects at 2 points. In the definition of injective function is intersects only at 1 point. Okay, so this is not injective function. Okay. But if we do another test point, for example, it also the same, right? Because intersects at 2 points, so this is not injective function. Okay. Okay. Now we identify the function x squared plus 10 is surjective function or not. Okay. For example, the test point is 30. Okay. This is a surjective because it intersects at 2 points, which I explained earlier. The surjective function intersects at least 1 point. In other words, minimum. Okay, minimum 1 point. But if we do another test point, for example, 8. Oh, this doesn't even cut the graph at all. So this is not a surjective function. Okay. Here I have written the test point is 8. And this has been proven that the horizontal line does not intersect the function. Or we can prove it with other numbers. Example, -5. Here still not cut the graph. So it has been proven that the function x squared plus 10 is not a surjective function. Okay, because it does not intersect the graph means that the function x squared plus 10 doesn't meet the requirements of injective and surjective function. So this function is not bijective function because it does not satisfy both. Okay. Now let's prove it with algebra. Okay. To prove injective function, I prove with contradiction. Okay. Contradicts the definition of an injective function, which states a function f, real to real, is said to be injective if and only if if and only if for every x1, x2 element A and x1 not equal x2, then fx1 not equal fx2. Take any fx1, fx2 element real with fx1 equal fx2. We'll prove x1 equal x2. Okay, so in the problem, n to n. Okay, because fx1 equal fx2, x1 square plus 10 equal x2 square plus 10, we remove 10. Okay, so only x remains. Therefore, we subtract by -10. So x1 square equal x2 square. Okay, we move x2 square, x2 square to left side. So x1 square minus x2 square equal 0. Okay, we factor it. X1 plus x2 times x2 minus x1 minus x2. I'm sorry, equal 0. So x1 plus x2 equal 0, or x1 minus x2 equal 0. X1 equal minus x2, or x1 equal x2. Then it is clear that the function fx equal x squared plus 10 is not injective because x1 equal minus x2 doesn't conform to the contradiction of the definition of injective x1 fx1 equal fx2. Okay. Okay, a surjective function proof. For every y element n, there is x element df such that y equal fx. Take any y element n, choose x element n. Illustrate if we know that the surjective function is Rf, or codomain. Okay. If x equal 1, implies fx equal 1 square plus 10 equal 11. If x equal 2, implies fx equal 2 square plus 10 equal 14. Okay. Well, from the problem, f n to n, which shows that the codomain function is a natural number, then the numbers should be 1, 2, 3, and other. One element natural number, but one not element Rf. So this is not a surjective function. Okay, because this is not injective and not surjective, then the function f n to n with fx equal x squared plus 10 is not a bijective function. Okay, this is so I can explain you. I'm sorry if any mistakes, and wassalamualaikum warahmatullahi wabarakatuh.